Hi, this is Pat Kerpan from Cohesive FT. I wanted to show you a few things today about connecting Docker containers over the internet and across the Amazon cloud. Cohesive FT makes a network function virtualization device, a software-only virtual appliance that runs in many clouds, called VNS3 or VNS cubed. And at its core, it virtualizes 6 network functions: router, switch, firewall, VPN concentrator, a protocol redistributor, so you can do things like use multicast in the clouds, which we've got some screencasts about, and a RESTful API, so you have a scriptable software-defined networking capability. Think of it as top of cloud, where your applications live. Well, what happened was we had customers asking us for more and more functionalities like SSL termination, forward reverse proxy, content caching, intrusion detection of various forms. And we wanted to think about how could we do that in a way where our customers would still have significant control. It wouldn't necessarily be just our functionality in this sort of layer 4 through 7 space, but they could bring to bear functionalities of their own, and that's where Docker comes in. So rather than building in a specific load balancer, intrusion system, threat detection system into VNS cubed, which generally runs as a mesh, 2 to 4 or more of these instances running in and across a cloud fabric, our customers can deploy their own functionalities via Docker in the mesh. And what happens is that turns out to be actually a pretty good way to have applications deployed via Docker in a highly scalable architecture across multiple regions in a public cloud. And I'll talk a little bit more about that in a second. So VNS cubed now ends up being, it's a network function virtualization device, but we actually have some customers saying, well, can't I run part of my apps in there and incorporate my own functionality very tightly on top of a virtual network? So what I'm showing here is basically VNS cubed devices living in the cloud. Let's talk about what they looked like in the past. Typically, our customers have run things like Amazon M1 small or C1 small, C1 medium instances. And they're basically as you see the little icons there, virtual switch, virtual router, the VPN functionalities, firewalling, etc. And that all happens in the overlay as they connect different clients and sites together. And it goes out over a tunnel adapter out onto the real cloud virtual machine adapter, which goes out onto the real hardware adapter, and onto the Amazon network for bulk transport across Amazon or onto the internet. So what's happened now with the Docker subsystem added to the VNS cubed devices, you've got that core functionality still sitting there with the tunnel adapter talking to the cloud virtual machine adapter, talking into the hypervisor switch, actually then talking to the actual physical adapter. And so our customers are running things like M3 mediums or C3 larges or C3 extra larges, is they basically begin putting their own functionality into our devices. So there you've got the Docker interface, and so you effectively have the Docker bridge or us inside our device acting not unlike the Docker bridge. And you can basically import Docker files, Docker images, allocate running containers, and they sit on that Docker interface, and then they have access, if subject to firewall rules and route announcements, they have access to the entire mesh network in and across the clouds. So what we're going to do in this demonstration is we're going to do something pretty simple. We'll have a container running in Amazon East on our Docker USA host, which you'll see here over to the left on the screen. And we'll have a container running in our Docker running in Amazon Europe. And we'll basically send secure network traffic from the container at 198.51.100.3 running in the Amazon East container to a .18 address in the Amazon EU container. It's obviously going out over the internet, but in this case VNS cubed is acting as an encrypted router so that traffic is sent safely to the other container across the internet. So let me orient you here if you've never seen VNS cubed before. This is the web user interface. Just a handful of things here. This is running in Amazon East. You can go, who is that address, and you'll find that that's true. It's running in an underlying VPC. which has this address block 172.31.1.0.24 probably. It's then creating a virtual overlay, virtual network. That virtual subnet is 192.168.79.0.24. We're not going to do very much with the overlay subnet. It's the encrypted overlay, because here what we're going to be doing is dealing with the Docker network running inside the VNS3 host, talking to another Docker network and another VNS3 host. You'll see links to other managers. Again, these are basically overlay network peers, so it is basically peered to this other device. And in the true sense, sort of like network peering, it sends routes that it finds out about. It sends route announcements across to its network peers. So we see we have one connected client, and as I said, we won't go too much into the overlay in this demonstration. And down below I can see system status and a few things like that. So what we'll do is we'll go look at our container menu, and we'll look at the Docker network here in Docker USA node. So here we have a 198.51.100.0.28 network. So that takes me from 0 to 15. And the way Docker setup works, the 0 and the 1 are reserved as well as the 15. So effectively, a few reserved addresses there. So we can configure this dynamically within VNS cubed instances. Obviously, if you go changing the network, you then have to stop and restart allocated containers so that they get an address logically on that network. So if I go over to my Docker EU and look at my network there, what I've done just to save some time is I've set it to the same overall network but a 16/28. So we pick up at the .16 and go to the .31. If I were doing that from sort of fresh as it were, let's change this briefly to 32.28. So basically we have the step here, validate. We just confirm that it's a logical network and we can make use of it. And then you can set it, and that then becomes the network on that Docker system. I'll set it back to my 16.28 for the demonstration purposes here. Validate. And it hadn't changed, so it stayed where it was. So once we set up those networks, then what we want to do on each of our managers is we want to advertise a route to this network. So it's a VNS cubed instance saying, hey, I know about this route. And you can attempt to send traffic and receive traffic from that route. So let's go here to my routes. And so here I'm basically just saying, I know about this route. And what we'll see when I go over to my USA manager, if we get to status fast enough, let's see, we don't see any routes there. So we'll see that route propagate through in a second. So now let's go grab my Docker network here. And I'll also advertise that route from this manager. And there I have. So basically I'm seeing locally, and it just reminds me that there's no encryption going on between my host and to the interior of the Docker subnet, since it's effectively running through memory, attached to manager 1. Then it shows me that I've also got access to this subnet, and that's over across on the other side of manager 2. So basically a peered, encrypted, routable overlay network. So the next thing I want to do is I'm going to need some firewall rules that basically says let traffic go from the Docker subnet on manager 1 to and fro the Docker subnet on manager 2. So not unlike a cooking show, I've got some of those sitting here in a buffer so I don't have to remember them all. Let me grab those. So on manager 1, basically I'm putting in a rule that nats traffic. So if for some reason I need internet services in my Docker containers, it nats them from their local manager out onto the internet with VNS3 acting as an internet gateway. And then I'm setting up a port forwarding rule that allows me to SSH in so I can do the demonstration here of the traffic from one to the other. And then basically I'm setting a rule that says this manager can forward traffic where the source is anywhere on the, I now have increased the two aligned subnets, and basically said /027. So that covers both subnets. If its source is that overall subnet and its destination is that subnet, I have a typo in my rule here. Allow the traffic to go through. And then here's one we might get to where we show effectively sort of in the cloud port mirroring. We'll see if we have time. So those rules have gone in, so let me go get the rules for my other one. And they're basically the same rules, only slightly different with respect to the port forwarding for the European manager, because I want to log into the container on that side as well. So I've got my firewall rules in, and so what I want to do is effectively now deploy Docker files or Docker images into the VNS3 overlay network, and then allocate running containers, or, you know, from a cloud point of view, we all think of them as instances when we deal with virtual machines. In Docker land, it's allocating a container. So if I go to the US East manager, I've already got an image imported here, so maybe part of the cake is baked. It's called TCP tools. It's basically just a simple image that has a set of TCP tools running it, like iftop, tshark, TCP dump for doing traffic analysis. But we'll go here and we'll allocate one from here. Basically, I'm just going to start the SSH daemon to give me access to this. So we'll call this Docker node 1 and allocate the container. And it comes up at my subnet there at a .3. I have another container running there that I was doing some analysis with earlier. So if I go over to the EU, we'll go through the full mechanism, and we'll start with images, and we'll see that I have no Docker images there. So what I need is I need my TCP tools container there, or image. So let me just give that a name, and in this case I've got basically an LXC container as opposed to a Docker file. And I'll grab that, and I can download it from a URL on the internet. So upload. So that while that's uploads, you can go to the Cohesive FT website, go to Products, VNS3, Add-ons. If you go to the Add-ons page, you'll find information here, documentation, and things about our Docker index elements, and things that are downloadable from our website that you can take a look at. So it's importing. We'll give it one more turn here too. There we go, ready. So that wasn't too bad, bringing across basically a base operating system image. So allocate one of these, and in this case it's basically the same operation. In this case I'll say Docker node 2, and my command, again I'm just using an SSH daemon to drive this container, where I have some other functions resonant. And it comes up on the .18 address. So really we're pretty close to home in that we now have an overlay mesh network made out of VNS3 with peered managers running in Amazon East and Amazon Europe. We have Docker subsystems in each with aligned, and they don't have to be aligned, in this case it was just simpler, aligned subnets for the Docker containers, and the necessary routes and firewalls to make them able to talk to each other. So we have running containers on both sides. And now let's just SSH in, and for the sake of, I guess, beyond verisimilitude, let's log in and take a look at these things. So I have my CFT demo prompt. So in this case, what I'm going to type in my CFT demo prompt is I'm going to log into the VNS3 manager in Europe, with that port redirection, I'm sorry, in the USA, with that port redirection, so that I can SSH into my container. So I'll do that. And basically, if I look at ifconfig, I see that I'm the 198.51.100.3. Let me go over to my second container, and I'll go to my demo prompt. And in this case, I'm logging in via SSH into the container in the European manager. And if I do an ifconfig, I see that in fact I am the 198.51.118 that we saw when I allocated the container. And so then I'll do a very simple operation. Basically, I'm just going to ping 98.18. So I'm just going, so in a sense, just reaching out, going to access some resources on that host. It responds 80 milliseconds. That tells you it's about an 80 millisecond world. It tells you I went, good ways around the world and back again. If I go over here in my other container and I do something like TCP dump, I don't want to see port 22 traffic, otherwise it'll go sailing by. And so now, of course, what you see as a result of me doing the TCP dump is I see the traffic arriving. In this case, because of one of the NAT rules I have, it's coming from the .254.1 as it's being forwarded by one of the VNS3 managers. And of course, from here, I can ping my host on the other side. So they're happily chatting away with each other. So really, again, what we've done is we've gone and sent secure network traffic from the container .3 across to the .18. So the other thing that I can do, let's go back to my manager, is that's quite interesting and motivated a lot of this, is customers want to be able to see everything going through their cloud network. So what I can do is, let's go back to manager 1. We see that we had the 169.79.1 device. So it runs over the tunneled overlay. So if we go to my firewall and we say, you know what, let's uncomment this rule. And so we have a simplified firewall. This is what's called a macro, custom macro. And it effectively acts like an IP tables chain. And here we just basically are saying, what I want to do is I want to copy all the data from 10.0 to my container network device at the .3, and then bidirectional, meaning all the traffic, both inbound and outbound, on the tunnel 0 interface. So what I'll be able to do, what you can then do is do things like, obviously with a simple rule, you can basically apply intrusion, extrusion type detection on your overlay network, running right there just off the side of the overlay network in one of your Docker containers. So let me go save that out. And we'll go back to my first container. So I'm the .3 who we've set to forward traffic to. So let me do a TCP dump. In this case, again, I don't want to see port 22 data. And what I'm seeing is, of course, still the ping coming to me. Sorry, let's stop the other fellow from pinging to us. So I'm back to my CFT demo prompt where I'll log into the overlay client. So this is running in the VPC in Amazon East. And it's attached via the overlay to the first manager. So in this case, if I do an ifconfig, what I see is I have my ETH0. This is my LAN address, VLAN address in the Amazon VPC. I have my local loopback, but I also have the tunnel address. Again, we talked about the encrypted overlay of 192.168.79.1. So the only other device I have on the overlay is the manager itself, and it has an overlay address of .253. So what I'll do here is I'll ping it. And so now let's go back over to my container one and redo my TCP dump. And so what we see is we see traffic going from 69.79.1 to the .253. So we're able to get a copy of the traffic that's traversing the internal network by having our container system and effectively having one simple rule added to our firewall to send a copy of those packets over to the container for analysis and review. Well, that's it for now in terms of how to send data safely and securely between Docker containers over the internet. to the cloud, through the cloud, across the cloud, using VNS3. Little advertisement here at the end for top 10 reasons to use VNS Cubed, but the essence of all of it really is millions of applications are moving to the public cloud, and everywhere those applications go, they need connectivity, integration, and security, oftentimes that can be controlled very directly by the customers who own those applications. And that's what we're here for. So thank you and have a good day.